Okay, so the document that I'm going to post, I've listed it over and there also at the very beginning. You cannot distribute this. Don't try to make money out of this. If the publisher finds out, they will sue you. The reason being the things that I've put in here in terms of the images and the problems, I took it from the textbook. So this partially belongs to the publisher. So don't sell it. You know, no quick rich scheme here. So the first thing that we have to know, if we have to understand a function, would be a relation. A relation simply means one thing is connected to another. A simple scenario would be, let's just say, it's not a true example, but I'm just making this up. So let's just say the type of food people like is related to the level of education. So first step is to identify what will depend on what. So which part is going to depend on the remaining part. So the level of education could depend on the type of food you eat, or the type of food that you prefer would depend on the level of education. By all means, in this problem, the reasonable thing to look at would be the type of food depending on the level of education. So here, Y would be the type of food people like the most. Let me just say like the most. And X would be the level of education. So I am going to define a few levels of education. Let's just say and the type of food, let's see, let the types of food be pizza, burgers. Well, the moment you get into masters and doctorate, you just start drinking a lot because it's frustrating. What should I put? Let's just say Chinese and steak. So you can see that I'm going in an order. So I start with high school, bachelor's, master's, doctorate. And in the same order, I have pizza, burgers, Chinese, and steak. So if I have to write these as ordered pairs, I would write it as high school is the level of education because it is an X value. That's how I defined it earlier. So X is the level of education and Y is the type of food people like the most. So the X value is high school. The corresponding Y value that they like the most would be pizza. The second ordered pair would be bachelor's. And the food that they like the most would be burgers. The third ordered pair would be masters. And the food that they like the most is Chinese. And the last one would be doctorate. And steak is what they like the most. So we tend to draw this diagram. Let's see if I can draw a proper rectangle here. It's probably not going to let me do it. Have to start and end in the same place. So I'm going to stick with the standard notation of an oval. Ah, look at that. It's good enough. Okay, so we have a set of X values. I'm going to write all the X values over here. And the Y values are over there. So high school, bachelor's, master's, and doctorate. Over here, we have pizza, burgers, Chinese, and steak. Again, in this problem, we can kind of do it interchangeably, but the reasonable thing to do is the type of food would depend on the level of education. So from high school, we can relate high school to pizza. We can relate bachelor's to burgers, master's to Chinese, and doctorate to steak. So here, the Y part, which depends on X, is what we call the dependent variable, because it depends on X. And the X part is the independent variable. The reason being, it doesn't depend on anything. So here, Y depends on X. So we call Y to be the dependent variable and X to be the independent variable. Later on, when we get into functions, we will stress this fact time and time again, because Y will always depend on X. So here I have a bunch of points, and I'm going to throw in this important word, which is a function. So every relation, every function is a relation. Let me write that here. So no matter what function I take, a function is always a relation in a mathematical sense, but every relation is not a function. And I will show you in the example as to what the proper way is to determine whether a relation is a function or not. So I'll pick that. Hopefully I get a nice little oval this time. Nope. We'll try it again. There. Wow. Well, great. Have like that. Copy. Paste. Okay, so the two ovals that we have, the first one is what we call the domain. The next one is called the codomain, or it's simply the range. Now, those are just fancy terms, but what do they mean? The domain is simply the set of all x values and the range would be the set of all y values. So if we go back to our food, type of food, and the level of education problem, the type of food, every single value that we had, the type of food that every single value that we have would be the y values, so that would form the range, and the type of, or the level of education would be the set of all x values, so that would be the domain. So the domain is the set of all x values, and the range would be the set of all y values. So that said, we know an ordered pair has x and y values. In this problem, or in any problem, the ordered pair, the first number would be the x value. I see 6, 5, 5, and 7. 5 is repeated twice, so I'll simply write it as 5, and 6, and 7. Those are the unique x values that we have. The corresponding y values are 6, 6, 6, and -2. So I'll simply write it as -2 and 6. So I could draw the lines like we did previously. Perhaps I'll draw a proper line this time. So 5 gets mapped to, oops, to 6. 5 also gets mapped to -2. And 7 takes on the value 6. And 6 takes on the value 6. So that would be the relation between the set of x values that we have, which is 5, 6, and 7, and the set of y values, which would be -2 and 6. So we want to know if this particular relation that we have is a function or not. So I'm going to write a remark here. So a relation is a function if one value of x has exactly one value of y. Now we could sort of get this by looking at the arrows, which is why we draw the arrows to understand the concept better. So if you look at 5, 5 is going toward two different numbers. One is -2, the other is 6. So 5 is an x value and it has two y values, -2 and 6. So clearly this particular relation cannot be a function because one value of x corresponds to two different values of y. So here, this is not a function. So in practice, we don't draw, the ovals and stuff each and every time. We look at a particular equation. We simply, know if it's a function or not by graphing. So when we get to a calculator, you will know just by graphing it if something is a function or not. Now you may ask me, like, why do we do this here? We do this here to understand the concept, of set of x values, set of y values, domain, and range. Okay, so in the next problem, we have 1, 2, 3, and 4. Those are the x values that we have. So 1, 2, 3, 4. The corresponding y values, they're all 1. So 1 is all we've got here. So 1, is related to 1. 2 is related to 1. Maybe use a different color. 3 is related to 1. And 4 is related to 1. And clearly from the picture, we don't have something like the previous problem where one value of x branched to two different values of y. Here we have single branches from each x or single arrows from each value of x to each value of y, which is just 1 in this problem. So here the domain is 1, 2, 3, and 4. The range is simply 1. There is a notation called the set notation, just like the way we have it in the problem. So you put within set brackets and you say, okay, the set of all possible values for x would be 1, 2, 3, and 4. The set of all possible values for y is simply 1, and that would be the range. Here, since a single value of x results in a single value of y, which is 1, this is a function. So here we have 3 ordered pairs. And the first number is 3/2. And I see a 0, so let me keep the order. So I have, 0, and I have 3/2. And we also have 1, 1/2. That's what we call a mixed fraction. I mean, it's 1.5. So what is 1.5? 1.5 is simply 3/2. So we multiply those two and add it to that 1 and divide it by the 2. So 2 times 1 is 2, plus 1 would be 3. So you'd end up getting 3/2. So 1.5 is the same as 3/2. So that number and that number are 1 and the same. And the other one would be 0. And on the other side, we have -7, 4/5, and 1/2. Now we can start connecting stuff. 0 goes to 4/5. 3/2 connects to -7, as well as 1/2. So the domain is 0 and 3/2. The range is -7, 4/5, and 1/2. So 3/2 is branching toward two different, branching towards two different y values, -7 and 7 and 1/2. So this is not a function. So here we have three values. For x, I'm going to put them in order: -3, 0, and +3. And we also have three different y values: -3, 0, and +3. So -3 from x goes to -3 in y. 0 goes to 0 in y. And 3 is going to 3. So the set of all x values would be the domain. And the set of all y values would be the range. So one value of x is going to exactly one value of y. So whatever we have here is in fact a function. So the relation is a function.